if this is the fabric, and if the objects are here and they bend it, like, is there anything on the other side of the fabric? If this makes sense.
No, because again, these are all analogy, or these are like these are visual analogies, right?
Okay,
so
yeah.
again, you have to sort of think, and this is another limitation of our human, our human apparatus, right? Again, our human machine. It's a limitation there. We're very, very limited machines in the universe, by the way. As you know, right? It's like, I mean, for example, again, going back to one of the other questions that one of the things we touched upon earlier, right? This notion that, there's a lot of people with dogmatic belief systems toward existence, right? And they're like, a deity created everything because look how perfect, it's like, someone of course had to create this. Look how beautiful things are. And look how, for example, take the human eye. Think about how perfect the human eye is. It could never evolve on its own. That's crazy. The human eye is terrible. Like, it's on cosmic scales, the human eye is a terrible experimental apparatus because it can only see electromagnetic the things in the electromagnetic spectrum between 400 and 700 nanometers. But the universe has an electromagnetic spectrum with frequencies that are far, far beyond all of those things. And our eyes can't see the muons coming in from outer space. It can't see the 65 billion neutrinos coming from the sun that are going through my thumb every second. So, again, our eyes are very bad from cosmic perspectives. And they're also, so our human devices, our human machines are very limited from that perspective. And it also breaks down when we start to have these analogies, right? When we're like, okay, so what does it mean for the Earth to create a sinkhole in space? Well, it's actually a 3-dimensional sinkhole, which is really hard to visualize, right? So there's nothing. If we did live in a 2-dimensional universe, right, and the rubber sheet was everything that existed, then it would be easier to somehow even that would be hard, right? Because you'd have to have a 2-dimensional thing. Again, the sinkhole analogy is really just like a heuristic to try to understand or try to visualize what it is. But then you have to always with the understanding that this is happening in all directions at once. So you have this 2-dimensional deformation. You also have the 3rd dimension deformation. I've seen a few people try to visualize this with various graphics that then show it, and they're okay. They do the best they can, but I think it's something that to a certain extent defies human visualization. So what's on the other side of the deformation is, nothing. There is no other side. It's just the 3-dimension. We're all embedded in the same 3 dimensions.
I see. This
One
makes
way to
sense.
think about it is a better way to think about it is not just a rubber sheet, but it's the one that's like the rubber sheet that has a grid of lines on it, right? Okay. And there's a grid of lines without the bowling ball, right? We have the rubber sheet, and you put like like just a regular grid paper lines, like white lines, right? And you see these. What these means, and this is important because within general relativity, when you have some object that's moving through space, it has to follow like a straight line. And so, which makes sense, right? If I have this sheet and I flick the marble, it has to go in a straight line. There's nothing to prevent it from moving. Maybe this goes back to to Newton, right? There's in the absence of some kind of deviating force, it's going to go in a straight line. This is the same way with general relativity. But then once you put and it's the same way, even if we put a bowling ball in the middle of the rubber sheet too, that marble is in fact going in a straight line from its perspective. There's nothing for it. No other marble came along to hit it. So it's going in a straight line. But from our perspective, we can see that the straight line is being bent because you have an enormous bowling ball there, and the straight line is bent a bit. So this maybe can help understand how it is that, if you extend this to 3 dimensions, then suddenly you can say, okay, the thing that I think is straight is actually, so straightness is relative in general relativity. And in fact, they have fancy names for these in the equations of general relativity and the tensor calculus that they use. These sort of, the fact that basis vectors, this is another mind-blowing thing for those of you that know some mathematics, the basis vectors can actually change as they move through space. That's a tough one for math people.